Good morning, and let's go ahead and talk about simplifying algebraic expressions. Okay, so this is a slide, again, when we talked about order of operations, I said we're going to see this quite a few times. So we're going to go ahead and talk about solving, simplifying, and evaluating. Today we're focusing on simplifying. We're looking at algebraic expressions that have variables. Okay, so that's a symbol that represents something else. So we could solve, okay, again, that's a lot of times when you see an equal sign, we're going to go ahead and solve for a variable, an unknown variable. Today we're looking at simplifying things. We're going to put things in the simplest form possible. And evaluate is when we have all numbers and we are going to, it's similar to simplifying except that if we have unknowns, we are substituting in a value, a number for those unknown variables. And then we are simplifying and then evaluating to find an actual numerical answer. Okay, so when we're talking about simplifying an expression, we need to know what parts of an expression there are. Okay, the term of an expression, when you hear me talk about the word term, it's the parts of the expression that are being added together. So for example, if I had the expression 2x plus 6, my terms would be 2x and 6. Like terms, in that particular example, I have no like terms, but they have to have two things in common. They have to have both the same variable, or they could have multiple variables in common. And those variables also have to be raised to the same exponent or the same power. So an example of like terms could be something like 2x squared and negative 3x squared. Okay, non-like terms. So just to clarify, because again, it's not just the same variable, but they have to be raised to the same exponent. So non-like terms would be something like 2x squared and negative 3x. They have the same variables, but they're not to the same exponent. This is x squared, and that's just x. So these are not like terms. Okay, variable is the number or the symbol used to represent a quantity that can change. So x, we don't know what x is. It could be 5, it could be 35, it could be negative 200. We don't know. That x is used to represent a quantity that may change. Okay, a constant is the value that does not change, or you could think about it as the number without a variable. So in that same example I had up there for term in 2x plus 6, the constant is 6. 6 is not going to change. It's being added to 2x, and x might change, but that 6 will never change. It's always just 6. And then coefficient is the number in front of the variable. So if I have, for example, 2x, the 2 is the coefficient. It's the number being multiplied by the variable, okay? 2 and x up here are being multiplied together, but again, the 2 is what we call the coefficient. It's that number in front. Okay, when we're looking at order of operations, okay, even when we're simplifying things, order of operations is important to follow. Okay, we have our grouping symbols, that is first. So our parentheses, our brackets, our braces, our extra long fraction bar. Exponents come next. Okay, this is called the base of our exponent. This is called our exponent or our power. Square roots or radical symbols, this symbol right here is called a radical sign. Those are both considered exponents. Okay, next would be multiplying and dividing. We work our way left to right. It's not all multiplication then all division, and we work our way left to right. They're on the same level. And same with adding and subtracting. We don't do all of our adding and then all of our subtracting. We do them at the same time, whatever comes first, left to right. Okay, so let's go ahead and look at a couple of examples. In this example, again, we are simplifying each expression. We are putting it in the simplest form we possibly can. So we are looking for like terms. Both of these have an x, and those x's both, well, they technically have an exponent of 1, but we don't have anything written there. So when I combine them, I'm simply adding my coefficients, 3 plus 6, well, because I'm adding because of this addition here. So I get 9x. That is as simple as I can make that expression. Okay, next problem. Again, we are making it as simple as possible. Well, this is the only thing with a W. There are no like terms. This negative here in front goes with it. So I'm going to write that first, negative 6W. And we'll talk about what standard form is later, but basically on this example, I want to write we're writing what we call the highest degree to the lowest degree, meaning I'm writing my terms with a variable first and my constant terms second. Then I have a positive 9 and a positive 5. When I combine those, I get a positive 14. These two values are not like terms. One has a W, one does not. So this is as simple as I can make that expression. Let's try some more. Okay, look for our like terms. Again, I'm going to look for my variables first. I have a positive 5h and a positive 7h. When I combine those, I'm going to get 12h. Then I have a negative 6 and a negative 8. When I combine those, I'm going to get negative 14. So minus 14. I can't combine the 12h and the negative 14. They're not like terms. One has a variable, one doesn't. That is as simple as I can make that expression. Okay, moving on. Again, like terms. Another thing, this only has variables. There's no constants in this particular example. We always want to work alphabetically. So A comes first. Positive 26A, negative 4A. I cannot add those other two terms to it because they have a different variable. So positive 26 and negative 4 gets me positive 22A. And then I have positive 2B and positive 10B. When I combine those, I get positive 12B. And there we go. Okay, moving on. We want to make sure these are like terms. Okay, so I have an A here, an A here. But if we look right from the start, this A right here has technically an exponent of 1, but we don't have anything written there. And this is an A squared. Well, they both have an A and a B, but the variables do not have the same exponent. This is B squared. That's just B. So those are not like terms. I cannot combine them. And then, in fact, that 7 doesn't have any variables at all. That's a constant. So none of these are like terms. So we have a couple options. Now, depending on whether maybe you're looking at a textbook or an online platform, different platforms ask you to write this different ways. One way I can write this as my solution is I can just simply copy it. Negative 4ab squared plus 7 plus 10a squared b. That would be considered correct because it's already in simplest form. So if I just copy it, it's still in the simplest form. Another option is we can just write already simplified. And that works as well. So I would take either of these. But again, depending on maybe in the future what class you're taking, different people might ask for different answers. Both of those in my class would be considered acceptable. Okay, let's again move on now. That's already simplified. We can't do anything with that one. So I'm going to start with what we call the highest degree, meaning I'm going to find the largest exponents. So I have a 4x squared, a negative 3x squared. None of the other ones are like terms because they do not have the same variable and those variables have the same exponents. 4 and negative 3. Well, we could write this as one of two ways. I'm going to just write this as x squared. If you wanted to write a 1 in front, that's fine. You don't need to. I would take, again, either answer. Then I have positive 2x, positive 8x. So that's going to be positive 10x. And then I have negative 7 and negative 6. When I combine those, I'm going to get negative 13. None of these are like terms. We have an x squared, just an x, and now a constant. We can't combine those. That would be considered as simple as possible. Okay, our last two examples for today are application problems. So we first need to talk about what the perimeter means. Okay, the perimeter is the distance around a figure. Normally, when I ask students, the way that they say it is, I just add up all the sides. I just add them all up, which is true. We want to figure out what is the total distance around this. If I were to put a fence around this triangle, I wanted to fence in this triangular area, maybe my backyard, I need to figure out how much fencing I need. That's what we're talking about when we're talking about the perimeter. And we're going to write it as a simplified expression. So I'm going to go ahead and write it out. I have 2x plus 1 plus x plus 3x. That's all three expressions added together. That's how we calculate or how we figure out what the perimeter is. So we're going to combine our like terms. I have 2x, x here. Now remember, even though I don't have it written there, if I just have x, I really have a 1x. So 2x plus 1x plus 3x. So 2 plus 1 is 3. 3 more, so I get 6x. And then I have just this lonely constant 1, so plus 1. That is simplifying. If, for example, I said, okay, well, now we know that x is 3, and I was asking you to substitute that 3, and I would be asking you to evaluate. I could say evaluate if x equals 3. But again, for the purposes of this lesson, we're just simplifying things. We're combining like terms and making the expression as simple as possible. Again, perimeter, so we're going to combine our like terms. So we have 17 minus a plus 4ab plus 5a minus 1. Well, this has two variables, so I'm going to make that one first. There's nothing else that has an a and a b, so I'm going to leave that by itself, so 4ab. Now I have a negative a, remember that's really a negative 1a, and a positive 5, so a negative 1 and a positive 5, so I get positive 4a. And then now I have positive 17 and negative 1. I'm going to combine those. I'm going to get 16. I can't combine anything else. This first term has an a and a b. The second term just has an a. That last term is a constant, no variables. I can't combine any of those. That is as simple as possible. Again, we could technically take these a step further. I could ask you to evaluate them using saying a is 7, b is 5, evaluate and find the perimeter. But we're not doing that here. We are simplifying. We are putting it in as simplest terms possible. If you have any questions on simplifying expressions, please let me know.